Hello everyone. So I will continue our discussion on the clustering analysis, and in this video I will be talking about more on the centroid based clustering. So let's turn to the seed data we have explored earlier, and let me go back. Let me load the cluster library and the seed data and add the variety. So if you're not aware of the data that then there might be scenarios where you don't know how many varieties of seeds are there in this data set, right? And what if there is no labels, right? And what seeds are of what type? So there are no rows name for this data, and plotting the dendrogram may not therefore be very useful. Instead, we can use the mean clustering. So what do you mean by the mean clustering is that in the mean clustering, the clusters are based on their distance to the cluster mean. That is called centroid. And when performing the mean clustering, that is the data split into the cluster based on their distance to the mean of all points. Points are then moved between the cluster one at a time and based on how close they are as measured by Euclidean distance to the mean of each cluster. The algorithm finishes when no point can be moved between the cluster without increasing the average distance between the point and the mean of their cluster. So to run the mean clustering in R, we use the k-mean, and let's start with the k-mean of value 3, right? And so what we are going to do, we are going to, so here I'm just ignoring the variable 8 variety, which is a group label. And to visualize the result, we'll plot the first two principal component. We'll use the color to show the clusters. Moreover, we'll plot the difference variety in a different shape to see if the cluster found correspond to the different varieties. So let's do that. And let me load the GG45. Yeah. So as you can see, there are three different clusters, and let me zoom it so you can see it clearly, right? And they are the two PCA component, PC1 and PC2. So what we can do, we can also change the number of clusters, right? So let me change it to 2, and there are 2. We can even change to 4, right? We can even change to 8, and let's also try 12. Let me zoom it. So you can see that these are the 12 different type of clusters we have created. So if it from the fact that different shape variety were shown as a different shape, we had no way to say but based on this plot alone. So what is the preferable here? And before we go into the method of choosing though, we'll mention PAM. So PAM is an alternative to the k-mean. So in the PAM, we use the PAM use the median as the measurement, which is called medoid instead of the cluster mean. And this is to make it more robust. Let's try with the K3, right? And let's see. Very similar result, but it is using a median instead of the mean. And there is a better way to visualize this. So Factor Extra package has some different functions. So Fivis underscore NB class is the one. So it has three different type of methods: the WSS, Silhouette, and the gap stat. So WSS yield a plot that relies on the within cluster sum of square, which is the measure of within the cluster variation. The smaller this is, the more compact are the cluster. The VCC is plotted on the several choices. So let me plot this one, and let's have a look at a different example using the we are using the PAM here, if you see, right? And let's use the method chill out. So it produces a plot which is based on the values how similar the point is compared to other point in the cluster. So the closer to the one, the value is the better, right? Let me plot this one. And finally, the method gap stat yield the plot of the gap statistics, which is based on comparing the WS's sum square to its expected value under the null distribution obtained using the bootstrap. So higher value of gaps are preferable. So it will take us second, 10 seconds. In addition to the plot of choosing the factors to provide a function called Fitch clusters for creating a PCA based plot and with an option to add the convex hulls or the eclipse. So let me show you that what I mean by that. So you see this is the using the Fitch underscore cluster and the points which you're seeing here are the row number. We can remove those. So let me run this. Yes. And even the shape of this cluster we can change to the normal distribution or the eclipse type. This looks really better. Now let's move to the next of the fuzzy clustering. An alternative to the mean clustering is the fuzzy clustering, which each point is spread out over the cluster instead of being placed in a single cluster. The more similarities to the other observation in a cluster, the higher it is the member in that cluster. Point can have higher degree of membership to the several cluster, which is useful in application where point should be allowed to belong to the more than one cluster. An important example here is in genetics, where genes can encode protein with the more than one function. If each point corresponds to a gene, it makes sense to allow the point to belong to several clusters, potentially associated with a different function. And the opposite of fuzzy clustering is a hard clustering, in which each point only belong to one cluster. So Fanny-form cluster can be used to perform Fanny. It is used to perform the fuzzy clustering. So let's do that. And if you want to see the membership, you can run this, right? And we can plot this again using the fizz underscore cluster. And again, how many clusters to use? So here it is chill out and both are optimal number cluster are presented here to use as 2, right? As for k-mean and pen, we can use the fizz and plus to determine how many clusters to use for our analysis. So let's also discuss the model based clustering. uh, so this is the last option. We'll consider the model based clustering, in which each cluster is assumed to come from a multivariate normal distribution. This will yield ellipsoidal cluster. Mclust is the package which is called a Gaussian finite mixture model. So I've already installed. If you don't have, please install mclust and create a data set and fit the model. So mclust from mclust package fit the model called Gaussian finite mixture model using the EM algorithm. So we are using the seeds data and let's plot this one. So as I told, it's use the Gaussian finite mixture model and based on the assumption that the data is numerical. For categorical, we can use latent classic analysis, which we'll discuss in other videos. For comparing the clusters, so having found some interesting cluster, we are often interested in exploring difference between the clusters. And to do so, we must first extract the cluster label from our clustering, which are contained in the variable clustering method, right? And we can then add those labels to our own data frame and use in the plotting. So let me do that. So I'm just adding those into the data frame, right? And let's load the ggplot and load this. So this is a box plot I'm just creating to compare different clusters. We can even use the density plot and even the we can create the scatter plot to compare each and every variables. It will take a second. Yeah. So again, how it is correlated and what the different clusters are compared to each and every variable, so you can use that. So more on this in the later videos. This is where we are ending our cluster analysis. Very brief introduction. And next I will be talking about the exploratory factor analysis.